For today's set of notes, we're going to start looking at tables and graphs. We're building up to be able to identify key features of functions and to sketch those graphs to illustrate those key features. But today's set of notes, I just want to review how to plot points, how to create the graphs. So if we look at this is called a coordinate plane. The horizontal, or the one that goes left and right, that's called the x-axis. The vertical line, or the one that goes up and down, is called the y-axis. When we're given points, the x always goes first, and then your y. So now we're going to plot some points. So let's say I give you the point of 2, 5. So if we wanted to plot the point of 2, 5, recall that this first one is the x, and this second one is the y. So now I would go to the x-axis. This is 0, 0. This right here is 0, 0. This is called the origin. I would go right 2 and up 5. 1, 2, 3, 4, 5. And I would have a point right there. I'm going to call this point A, and I'm going to label this point A on my graph. Let's do another point. Let's go to point B. So what happens if this x value of 2 becomes a negative 2? So if we have the point negative 2, 5. Within the negative 2, I would go left 2, and then still up 5. 1, 2, 3, 4, 5. And we're going to call this point B. All right, let's do another point. I'll call this point C. What happens if the 2 stays positive and the 5 becomes negative? So our 2 is positive and our 5 is negative. So if our 2 is positive, I would go 1, 2. But now a negative 5, 1, 2, 3, 4, 5. And this would be point C. Well, let's do one more. What if the 2 is negative and the 5 is negative? Where does that point go? So at the origin, 2 is negative, so that's left 2. The 5 is negative, that's down 5. 1, 2, 3, 4, 5. And point D would go down here. So that is just a review on how to plot points on the coordinate plane, because we're going to need that for this unit and all the other units. What if you're given a table? How does it work from a table? So if I'm given this table, the one on the left are my x's, the one on my right are the y's. This is just another way to write points like we did on part A. So these are still kind of written as points. I'm going to label these A, B, and C again. So if I want to plot point A, a positive 2 and a positive 4, recall this is my x-axis. It's always a good idea to label these so that you remember. So A, 2, 4. Right 2, up 4. 1, 2, 3, 4. So this is point A. B is negative 3, 3. So negative 3, 1, 2, 3, up 3, 1, 2, 3. There's point B. C, 4, negative 5, 1, 2, 3, 4, 1, 2, 3, 4, 5. So that is C. So that is just being able to plot from a table. If we look at part C, this is really the big idea that we're trying to get to, that we give you what's called a function or an equation, as you could see. We're going to give you the x values. We want you then to complete the table with the y values. You're going to plot those points and you're going to create a graph. So I'm going to go through about 7 examples with you. So I'm giving you the x's, And what you would do, you would substitute in each one of these x's to find their y's. Now, depending on the calculator you have, you may want to go back and look at the video I made was showing you how to use a graphing calculator, a scientific calculator, and the Desmos calculator if you don't know where I'm getting these answers from, because those can help you know how to put them in. So if I take -2 and I substitute it in for this x, -2 plus 2 is 0. -1, substituted in for x, -1 plus 2 would be 1. 0 plus 2 is 2. 1 plus 2 is 3. 2 plus 2 is 4. So now I have 5 sets of points. I'm going to plot those points. -2, 0, -2, 0 means you would just go left 2 and you would not go up and down. -1, 1, 0, 2, 1, 3, 2, 4. And now we're actually going to plot those points, and these are just going to keep going. So I'm going to put arrows at the end because this is a line that's just going to keep going. Example 2. Now I have an x squared term. So when I substitute -2 in for the x squared, I would have to square first. So -2 times -2 is a positive 4. So it looks like this. -2 squared plus 3. -2 squared is a positive 4 plus 3 gives us 7. -1 squared is 1 plus 3 is 4. 0 squared is 0 plus 3 is 3. 1 squared is 1 plus 3 is 4. 2 squared is 4 plus 3 is 7. So now I would plot those points. -2, 7. -1, 4. 0, 3. So 0, 3, I do not go left and right, but I do go up 3. 1, 4. 2, 7. Starting from the left, if I connect these points, you should actually have a U shape. This is a U. This is called a parabola. It's making a shape of a U. Slide down here to examples 3 and 4. These bars right here, these are called absolute value bars. If you call absolute value, when you take the absolute value of a number, it always turns out positive because it's the distance from 0. So if I substitute in -2 for x, order of operations, I'm going to do what's inside here first. So -2 minus 1 is -3. But now I want to take the absolute value of a -3, which is a positive 3. -1 minus 1 is a -2, but the absolute value of a -2 is a positive 2. 0 minus 1 is a -1. The absolute value is 1. 1 minus 1 is 0. 2 minus 1 gives us 1. So -2, 3. -1, 2. 0, 1. 1, 0. 2, 1. Now, look at this kind of interesting shape. If I start from left to right, I actually have a shape that looks like this. This shape should be a V. Number 2 is a U. Number 3 is a V. So make sure you're connecting that as a V. Example 4. All of this is an exponent. So that x plus 1 is all the exponent. I'm going to substitute in -2 for x. negative 2 plus 1 is negative 1. So really you have 3 to the negative 1 power. When you put that in your calculator, so when I put, let me bring my calculator over. So when I hit 3 and raise that to the negative 1 power, and I hit enter, you get a decimal, or you get a fraction of a third. So 0.333333 is really 1/3. So this is 1/3. So then I substitute negative 1 plus 1 is 0. So this is 3 to the 0 power. 3 to the 0 power. So if I put that in my calculator, 3 to the 0 power, look at that. That's actually 1. So anything at 0 power is 1. Substitute in 0. 0 plus 1 is 1. 3 to the first is 3. Substitute in 1. 1 plus 1 is 2. 3 squared is 9. Substitute in 2. 2 plus 1 is 3. 3 to the third is actually 27. So negative 2 and 1/3. So negative 2 and 1/3 is down just, negative 2 and a positive 1/3 is up just a little bit from 0. Sorry, ignore that one. Negative 1, 1, 0, 3, 1, 9, 7, 8, 9. We're going to go off. We're definitely not going to fit 227. This makes a J graph. So it looks like a J. We call this a J graph. And it would have arrows at both ends. Example 5. We have the square root of x, and then outside we have minus 2. So keep in mind, the only thing that has a square root underneath is that x, and then the minus 2. So if I take the square root of 0, that's 0, minus 2 is a negative 2. The square root of 1 is 1, minus 2 is a negative 1. The square root of 2, I'm not really sure what the square root of 2 is, so let's put that in our calculator. So I'm going to get the square root of 2. I'm going to hit enter and get that answer. Then I'm going to subtract 2 from it. So we get, this is negative 0.59. We're going to go ahead and round that. 4. I do know the square root of 4 is 2, and 2 minus 2 is 0. What about negative 1? I don't know what the square root of negative 1 is. So if I get the square root of negative 1, says this is a non-real answer. So we cannot take the square root of negative 1, which means this is not possible on this graph. Because it says I get a non-real answer. So let's plot what we know. 0, negative 2. 1, negative 1. 2, negative 5.9. Well, 0.5 is here. So it's a little bit closer to negative 1. So I'll go down a little bit. 4, 0. And that's as far as I can go. And this one looks kind of shaped like this. This only has one end. It actually does not have another end. So just one end here. Only goes in one direction. So from left to right, it would go like this. Because we saw that negative 1, it's not possible. So there can't be anything on this part of the graph. Okay, cubed. So I'm raising it to the third power. Negative 2 to the third. So I'm doing negative 2 to the third. Well, negative 2 times negative 2 is 4. Times another negative 2, this would give us negative 8 plus 3. So somebody says -5. -1 cubed is -1, plus 3 is 2. 0 cubed is 0, plus 3. 1 cubed is 1, plus 3. 2 cubed is 8, plus 3. So -2, -5, -1, 2, 0, 3, 1, 4, and then 2, 11 I can't get on there. So from left to right, if I start connecting my points, remember we know that 2, 11 is way up here. So this is what that graph would look like. Last example, this is the cube root. Cube root, because there's a 3 there. So number 5 was called the square root. This is called a cube root because of this 3. So now I'm going to substitute in -1. So I get -1 minus 2 is the cube root of a -3. I don't know what that is, so I'm going to put that in my calculator. I'm going to hit math, and I'm going to go to number 4. So it shows a cube root of a -3. So it gives me a decimal of a -1.44. 0 minus 2, that's -3. I do not know the cube root of a -2, sorry. 0 minus 2 is a -2. So I'm going to go to math. I'm going to do the cube root again, and I need to know the cube root of a -2. Okay, that's -1.26. 1. 1 minus 2 is -1. The cube root of a -1 is -1. 2 minus 2 is 0. The cube root of 0 is 0. 3 minus 2 is 1. The cube root of 1 is 1. So I plot that. -1, -1.44. 0, -2.6. 1, -1. 2, 0. 3, 1. So this actually looks like that. And it has arrows that go in both directions. So as you're working these out, you need to check with whatever calculator you're using and make sure you're able to generate the points on the graph. If you're not really sure where I got those and you need help with your calculator, that's the time you ask your teacher, or go back to Canvas and watch the videos of where I show you how to do some of the techniques in your calculator.